to approximate the cube root of 1001. And this is on page 259. Okay. If I'm asked to approximate this, I will immediately write the formula. F of x plus dx is approximately f of x plus f prime of x dx. And I know that I don't even need to think about this side. I need to determine the function in here. I need to find the x. I need to find the tiny dx in here. All these answers come from this. And then I will differentiate f prime of x. Once I have all these, this is just fill it in. I don't have anything to say there. Mechanically, I will put the numbers in, or the expression, or whatever I have. So can anyone look at this carefully and tell us what is the function, how much is x, how much is the tiny x, and how much is f prime? And then the problem is solved. Once I identify these, I'm done.
F of x should be x to the power of 1 over 3.
Yes. So it's the cube root of x, perfect, and or x to 1/3. Excellent. Yes. Good. What about x?
It's like 1,000.
Exactly.
1001, yeah.
So see, it's x, which is big, and dx, which is small. I cannot say that x is 1001. I have to decompose it into two different pieces. This, which is big, and this is very, very small by comparison. So what can dx be?
It could be 1.
Exactly. Good. So now f prime is clear. I bring down 1/3. X to 1/3 minus 1 is negative 2/3. And now I can fill this in with exactly what I have here. So if x is 1,000, how much will be f of x? If x is 1,000, how much is f of x?
Just 10.
That's it. This piece is 10. You already told me that dx is 1. And now we have to plug in 1,000 in here. So this will be f prime of 1,000 is 1/3, 1,000 to negative 2/3. So when I take the cube root, and I will write it as 1 over first. 3, 1,000 to 2 over 3. So first I apply the cube root and I get 10. And 10 squared is 100. 100 times 3 is 300. So this piece is 1 over 300. So I determined everything. And I can go back, continue here. I have 10 plus 1 over 300. Or 3,001 over 300. So this is approximately 3,001 over 300. Please do not approximate. Do not use decimal numbers. That's all I need. Of course you will check. You must check. You don't want to miss any points. So of course you will check. So you will go to the graphing calculator. You will take 1,001 to power 1/3. That's not what I meant. To power 1/3. And of course, you will press enter and you will divide 3,001 by 3,000. dx is very small by comparison to x, so this should be a very good approximation. Gee whiz, it's a very, very good approximation. because dx is very tiny in comparison to 1,000. So this is a very minor error. Now, if I have a 1,050 and dx is 50, the error is not going to be that small. Okay, very good. Ready for your questions. Anything that you found that we should look at? Anything, please. Anything you need help with?
So I have two questions.
Yes, I'm ready.
I have two questions. The first one is use the logarithmic differentiation
Yes,
to find the derivative of the function.
yes,
And the function is y equals sine, open parentheses, 3x, close parentheses, and then the exponent is ln of x.
you mean here.
Is ln. Yeah, and then it's l. Yes. Like that.
Okay, perfect, perfect. Okay, so let's work on this first.
Talia, are you getting it from the book?
Yeah, this is actually from WebAssign. This is 3. Give me 1 second. This is 3.6. The derivatives of logs inverse trig function.
All right, thanks.
Good.
You're welcome.
So there is no rule. If you want, there is a procedure, but there is no rule for this. So the procedure is, step number 1, you apply natural log. Natural log y. When I apply natural log, the power comes in front. So that's my first step. In step number 2, I have to differentiate. And this left-hand side, it has to be differentiated implicitly as 1 over y times dy over dx. So far, so good. Any step, any question on this step?
So far, so good.
Now I have to apply the product rule. So first I differentiate natural log x, and I get 1 over x times this, plus I copy natural log x, but now I differentiate this one, which is 1 over sine 3x times the inner function prime times the innermost function prime. Function, function, function. I differentiated this as 1 over sine 3x. I differentiated this as and get cosine 3x. I differentiate this and I have 3. Okay, now I have 1 over y dy over dx equals. I want to condense it before I multiply by y. So natural log sine 3x divided by x plus natural log x cosine over sine, so I have natural log x, and with a 3 in front. And then cosine over sine is cotangent 3x. Cosine is in the numerator, sine is in the denominator. Now I write dy over dx equals. Multiply both sides by y, but I will replace that. Sine 3x raised to natural log x, because that's what the y. In brackets, careful, in brackets all this. So natural log of sine 3x over x plus 3 natural log x cotangent 3x. Any questions on this? On any of these steps? Is anything confusing here that I need to go back to? Anything? Is this okay? Every step, please. Anyone say something, please.
Can you
Yes,
just
it's
repeat
okay.
the steps, please? Thank you.
You want me to do what, Evelyn?
Repeat the steps.
First I apply natural log. When I apply natural log here, I have to bring the power down. I differentiate this implicitly 1 over y times dy over dx. I differentiate this as a product. Natural log x prime is 1 over x. I copy the second plus. I copy the first and I differentiate the second. 1, 2, 3 functions. First I differentiate natural log, 1 over sine 3x. Then I differentiate sine x and I have cosine 3x. And then I differentiate 3x, which is 3. and then I just condensed a little bit. And then multiplied by y. So I wrote this here, and then cosine over sine is cotangent, and 3 goes in front. And then I multiply both sides by the given function y. But I replaced it by the given function. And there is no point in writing y and then replacing it by sine 3x to natural log x.
Okie dokie.
Okay. Is this okay, everyone else?
Yep.
All steps clear? Okay, what was the second one? So I thought you had 2 questions, or we move on? You are muted. Okay, I'm not sure. So we continue with other questions. Yes. Anyone else? Yes.
So on WebAssign,
Yes, I'm ready.
there's a question.
Yes.
It's about like gravel being dumped from a conveyor belt
Yes.
at a rate of 30 cubic feet per minute, and its coarseness is such that, or should I just look it up?
Yes. We did this problem last time.
Oh, we did.
I just
I can look at it.
I just threw it in. I just threw it in the recycle bin.
Oh, I could look at it then.
No.
It's on the,
No. Maybe not. Maybe not. As I said many
I'm sorry,
times.
Professor, thank you for going over that problem. I have one more once everyone is at the
Yeah.
question.
Sure. So here it is. As I mentioned many times before, when you get to my age, you always want to check your memory. So the height and the diameter will always stay the same. How they manage that, I'm not sure. But this is given in the problem. This is not when at the instant, it's not the trap. And then I was telling you that the volume of a cylinder and the volume of a cone are very well related. So if you remember the cylinder and you divide by 3, you will get the cone. So then we did this. We had to replace the radius in terms of the height because we don't know anything about the radius. They're telling us about the diameter, and they only want us to find the rate of change of height with respect to time. So we differentiated implicitly, and then we got this. And we plugged in all the numbers. The numbers come into play only at the end. Unless they're telling us from the very beginning that this equals this and it's carved in stone forever. Then we have to take that into account from the beginning.
okay, yeah.
So were you given 10 feet or something else?
I was given 5 feet.
Okay, so all you have to do then, change the height from 100 to 25. So you still have 30, you still have pi over 4, you still have 5 at 5 squared, which is 25. So you have 30, pi over 4, and 25.
Okay, thank you.
Thank you. Good. Yes, what was the second question?
So my second question was the
Linearization, yes.
function?
Linearization, yes.
Yes,
The linearization
So-
is f of a plus f prime of a times x minus a. This is the linearization.
yes.
Good. And they're giving us a
So the
function,
question,
and they are giving us a.
yes.
Perfect.
So this is, for anyone that needs it, this is from 3.10, linear approximation and differential homework, if anyone needs it. It's f of x equals x to the power of 3 divided by 4. And then a equals 16.
Perfect.
I just wanted to go over how to do it again.
Sure. So first of all, let's find f of a. So I have to plug in 16 here. So f of 16 will be 16 to 3 over 4. The fourth root of 16 is 2, and 2 to the third is 8. So I found this piece, which is 8. Then I have to differentiate. So f prime of x is 3/4, x to 3/4 minus 1, which is negative 1/4, which is this piece. And I have to plug 16 in. So f prime of 16 is 3 over 4, 16 to negative 1/4. Better to change this into a fraction, 3 over 4 times 16 to 1/4. The fourth root of 16 is 2. 2 times 4 is 8. So this answer is 3 over 8. So this piece is 3 over 8. And this piece is x minus 16. So now we put all pieces together and we get the line. So L of x, the linearization of f of x at 16 or near 16 is 8 plus 3 over 8 x minus 16. I will distribute 3 over 8x minus 3 over 8 times 16 over 1 is 6. How do I know? 3 over 8 times 16 over 1, I simplify, and I get 3 times 2 is 6. And I have to add 8. So L of x is 3 over 8x minus 6 plus 8, which is positive 2. So 3 over 8x, and that's the line that approximates this function near x equals or a equals 16. So if this is the graph, and this is a equals 16, and this is the line, if this is the line, then I can use this line L of x instead of f of x near 16 to approximate the function. That's all it means.